This is the phototype circuit of our project. This project contains 4 main parts. They are sensing part, controlling part, processing part, displaying and communication part. First, boot up the system. Press number 1 of the 4x3 membrane switch keypad matrix keyboard. Check SpO2 level by using MAX30100 heart rate and pulse oximetry sensor. This result displays on the 128 by 32 Adafruit OLED. Press number 2 and read heart rate using same sensor. In here, touch the sensor and capture the video at the same time. Therefore, short result is somewhat less valuable. Serial monitor shows the serial data which varies with censoring time. Press number 3 and read MLX90614 contactless temperature sensor module data. Both the above sensors are used I2C communication. Therefore, MUX has been used. Press number 4 and read AD8232 electromyogram EMG muscle signal sensor data. Read stored data in SD module. This data sent to the ESP8266 module. Atmega 2560 works as a master. ESP8266 works as a slave. Display and plot the real-time data in Blinky IoT platform. Let's clarify the implementation. Plot the frequency spectrum using fast Fourier transform. This implementation method goes through 5 steps. High pass filter used for remove the baseline wonder. Low pass filter used for remove the EMG noises. Differentiator filter used for remove the small fluctuation of the signal. These are impulse response filter calculation methods for above processing. Moving average window integrates the output signal of the squaring process by using this equation. Then we can clearly identify the QRS peaks and heart rate. This is the Android app Simunic model. This mobile app shows filtered ECG signal and other details. HC06 module used to send data to the Android app. We can control the sensors by using this. Finally, we designed a PCB for our COVID test kit. It is low cost, reliable and very easy to handle.